All right, well, let's get started with some introductions here. Let me throw, yeah, so I'm Dr. Danny Klitich. I'll be the host today for this webinar. I'm based in California on the coast, so I cover a little north of Los Angeles to a little south of San Francisco. On the coastal side, never get more than about 30, 40 miles from the ocean. So so I'll be leading most of the discussion, a couple of the trial results that we have today, and then joining me also is Jeff Yoder. Jeff, do you want to introduce yourself a little bit as well?
Yeah, I'm Jeff Yoder. I'm the Redox agronomist for row crop for the Pacific Northwest. I cover Washington, Oregon, and a little bit of Idaho. I also get down to Yuma, Arizona once in a while. I've got a trial down there I'm going to talk about today. But I deal mainly with row crop in this region.
Great. Oh, put that right on. Thanks, Jeff. Okay, let's see. So let me get my slides pulled up here. That one. Okay, where is it? There we go. Okay, so y'all can see that? See a title slide? Thank you, Jeff. Okay, so here's kind of the agenda for today that I wanted to kind of go through. Basic introduction. Sam is also joining us. She doesn't have her camera on, but Sam's based in Idaho, and she'll be helping us on the backside of it, making sure people are muted, unmuted, and taking care of that type of thing. So I can, yeah, so that we can go through here, and hopefully it goes cleanly. Sorry, somebody just texted me saying they've got an issue getting in. Okay, so we're gonna go through phosphorus. Wanted to talk a little bit about kind of the dynamics of phosphorus in the soil, what the challenges are there. It can be a major input in a lot of different markets. Talk about some input selection and kind of how those dynamics influence your choices and rate selection and timings, and then run through a couple products as well as timings and programs that we've had success with in the field, yeah, and go from there. So if you have any questions throughout, here's my housekeeping slide. Here we go. Questions. Please ask. There's a questions function. We'll try and keep an eye on that. Also, there's a raise hand button on your screen that you're welcome to do that, and it'll pop you up to the top of the queue here, so that we can kind of hopefully get our attention there. Or of course, you all have the ability to speak during the talk if you'd like. So you can just unmute yourself and talk and interrupt me, and we will happily answer your questions along the way. We had some issues on the last webinar we did last week where some of the questions got asked and then we didn't see them as quick because it doesn't ding or anything on our side. So we'll try to do a little bit better this time to answer questions as they come through. So with that, if you do have the ability to use headphones, that's helpful to improve quality and also prevent feedback. If there are multiple people watching the same webinar in the same room, just try and use headphones or something like that, because there can be a lot of feedback and we can get some pretty nasty sounds coming through. And if you're on a mobile device, you can leave the app and come back and it should just keep playing just like you're listening to music or something like that in the background. So that is a nice feature. I did find out yesterday, I was on another webinar, and if you are driving around, it'll play through your Bluetooth just like a phone call. So it's kind of a nice feature if you want to get in and out of your car. It should just automatically pop on. At least it worked in my Ford. Did that. So okay. So who's Redox? So the purpose of Redox is we exist to create passion and excitement in growing plants. Have kind of three core values that I wanted to highlight here. Passionately authentic, or excited and caring, engaged with our community and industry. You get what you see. And then creatively driven. We're always looking to kind of push the boundaries of what we know about production systems, and help to improve them and innovate those improvements. And then also scientifically knowledgeable, proficient, educated in our discipline, and try to be at the top of our field. Well, click on the right screen here. There we go. So Redox is a bionutrient company that focuses on sustainable plant nutrition, simply put. So today I wanted to highlight phosphorus and kind of go through there. It's a nutrient that has some unique attributes to it chemically, and it is a major input in many crops and can be a limiting factor in a lot of different crops and a lot of different soils for many different reasons. I wanted to check one thing here before we really get rolling. Okay, there we go. Okay, cool. We have, before we get going, I just want to say we got 47 people on this webinar, which I'm very excited about. So thank you everyone for joining. This should be, I'm hoping to be about 30 minutes or something like that, depending on questions. And we got people on here from Washington like Jeff, as well as down in Georgia and Florida area, California, and I think we got some guys up here from Michigan as well. So we got all over the country represented. So appreciate everybody logging on around your lunch hours and later here. So so phosphorus, let's jump in. So phosphorus in the plant plays many different roles, but one of its major roles is part of ATP. It's the energy currency of the plant. So when we think of phosphorus, we can think about energy in the plant, energy movement, energy transfer, and the currency of energy. The roots play one of the major roles of roots, obviously, is nutritional uptake. And one of the major ways that phosphorus is found in the soil by the roots is by root interception, which means as that root grows, it finds pockets of available phosphorus and can pull them in. So we need to have root growth to intercept phosphorus. The other way that phosphorus is made available is through biological availability of that nutrient. So there's interactions with the soil microbiology to bring phosphorus into the root. So I want to stop here and try a poll. So let's launch the poll. So first question there, if you've got your phone out there, it says what percentage of phosphate is 1034O is plant available? So when it gets to the farm in your tanker truck or on your pump off, what part of that is phosphate the plant can take up? So go ahead and answer that question. There's a second question right below that'll let you read that one, and we'll give it a couple minutes, or give it a minute or so here so people start clicking through. And then we'll share this. And this is anonymous, so it's not going to tell everybody what your guess was.
Yeah, I'm sure it's anonymous. You want to catch us, Danny?
Well, I'll know what you answer, David.
I'll go back to mute. Bye-bye.
Okay. So we got about half the audience there. Okay, a couple more seconds, and I'm going to close it, and we'll see what everybody says, and then we'll talk about kind of what I talk about these questions, I guess. Is that your final answer? Okay, hit that submit button. I'm going to close the poll. Okay, so the first question, what percentage of phosphate in 1034O is plant available when it gets there? So when it gets to the farm, it's 100% available. That phosphorus, or 70 to 100% available, that's in that product is there. There's some that's tied up in calcium phosphate. You'll see that in some of the precipitate that falls out in 1034O sometimes. But the majority of the phosphate that's in that is coming through is plant available. Now the problem, however, and that's where this question comes, is this: when you put it on the soil, chemistry starts happening, or you start mixing with water, chemistry starts happening, and that phosphorus starts tying up quite readily, and that's where you get this 0 to 15%, kind of probably in the single digit range of efficiency out of the pounds of phosphorus applied that the plant is actually able to get taken up. Oh, look, there's a share results button. Sorry. So there's the results. There's just a little nuance there between the two. So you'll see a lot of the time that this holds true for many different inputs, that they're built to be 100% plant available. The problem is when the chemistry starts happening in the environment is where everything kind of changes. So let's see. Stop sharing. Go away. Okay. Well, Sorry, it's popping up on my screen. Okay, so what phosphorus in the soil? So it's on the coast here in California. We have what are generally known as high phosphorus soils. We can have this very high phosphorus number, 106 ppm, fairly high phosphorus. However, the solubility of phosphorus in the soil is extremely low. So there's a lot there, but there's not a lot actually readily available to the plant, and that can cause some limiting factors. Now, a lot of that is due to the fact that the phosphorus ties up readily in the soil with other cations. So I want to show a little demo here of what that physically looks like. Is a calcium solution, similar to what we would see of calcium in solution in the soil, simulating that. And then what I have here, I'll get this in here, is some beautiful green 1034O. So many of you have probably done this on accident into a fertilizer tank and know what's going to happen here, but let's see if we can put a little 1034O in the calcium solution. And you can see that the 1034O immediately reacts, that's calcium phosphate that's formed, and turns it into gel that people get to clean out of their drippers or sprinklers if you do this in your fertilizer tank, or your application heads, or the root then has to go try and then dig that back out of the soil. So we put out our 1034O into the soil, and we end up with calcium phosphate. Now, the plants have the ability to come in and mine this calcium phosphate for phosphorus. So they can do that by producing organic acids. So I have some acid. We can put that in here. Put some acid in. You can see that when the root acidifies the solution, we solubilize some of that phosphorus and that calcium, and what goes back into solution, and the plant can pull that back up. Now, producing the organic acids that are needed to make this reaction happen, however, are very energetically expensive. And that's why a lot of our photosynthates come out of our roots and are used for mining nutrition out of the soil and feeding the soil microbiology. So ideally what we want to do is provide nutrition to the plant, to the tree, the crop, and that is available so that it can be used by the plant immediately to support that growth stage of the crop. So we're going to talk about that now. Okay, so let's talk about that. So how do we get phosphorus that's tied up in the soil to be available for the plant to take up? So the first challenge, I guess, there is soil biology. We want to have a diverse and vigorous soil biology to help cycle phosphorus out of that bound up form and make it plant available. We have in many soils a reserve of phosphorus in the soil, but we don't have it where the plant can use it. So the key here is promoting biological activity in the soil through organic matter applications and other management tactics to make sure we don't damage that and keep that at the highest level we can, and that will help with nutrient availability, especially phosphorus nutrition. So the key there is high levels of soluble carbon in the soil form soil microbial activity will enhance the natural complexing of phosphorus, reducing calcium and phosphorus tie-up. So we can do that through input additions and then promoting good soil structure, and that will help grow that soil microbial community and get us some more nutrition. So the next part, so that's what we can do with the phosphorus that's already in our soils. But what can we do with the inputs when we're trying to put phosphorus in? So phosphorus applied nutrition, the challenge is that tie-up, right? So if you're too common, this is two common calcium reactions. Phosphorus has two negative charges on it. Phosphate has two negative charges on it, so it binds up readily with cations, especially divalent cations, calcium, zinc, some forms of iron, things like that. So you can form these very strong phosphate bonds that can be challenging for the plant to access the phosphorus part and the cation that's associated with it. And we'll talk about that a little bit more. It can have some ramifications, not just for phosphorus nutrition, but other nutritional inputs. So the key there is preventing that phosphorus tie-up through properly complexing that phosphorus, satisfying the charge on it so that we limit the tie-up in the soil and increase the plant availability and the ability for the root to pick it up and use it. So here's a graphic of that. So we can take unprotected phosphorus that's binding up. We take a phosphorus input and manufacture it to be stabilized through amino acids, fulvic, humic, other complexing agents, and that will allow it to be plant available and limit the tie-up with calcium and other inputs. So I wanted to talk about, kind of highlight 3 redox products that I think are relevant in the discussion of phosphorus nutrition of the plant, and not all of them are actually phosphorus inputs. So the first is H85, which is it's a humic acid based product. It increases microbial diversity. It has 85% soluble carbon, improves soil microbial diversity and health. It also can improve nitrogen inputs as well as phosphorus, and it's soluble across a broad range of pHs. We also have an organic version of this that's also on the market. The next product would be Redox, which is a phosphorus input. We're going to talk about several different places where we've used Redox extremely successfully and timings that we found that Redox can really outcompete a lot of the traditional phosphorus inputs for phosphorus efficiency in both the cost and the crop response. So it's a 640-6.5, reduces soil phosphorus tie-up with calcium as well as other cations, improves phosphorus efficiency, and promotes root growth. There's 8% amino acids and 3% humic acid in this product, and those are used in the processing to stabilize that phosphorus anion and keep it in a stable form so that when we put it out, it doesn't immediately bind up in the soil, and it remains available for the plant to take up, and the plant can see that as phosphorus and the chelate and the complexing agent, and can take both those up and use those as energy in the plant. Okay. We also have a convenient flowable version of Redox that came out a year or 2 ago. It's a 215-2, same technology, in some cases even better efficiency, just through the manufacturing process. So a very nice, easy to use product. The last product I wanted to highlight, and then we'll get into some examples of timings and how they work, is Expect. So Expect's a new product for last year. It's a phosphorus metabolic primer. So it's got a little bit of nutrition there at 203. You'll note no phosphorus. However, what it's extremely good at doing is blending with phosphorus products and helping the roots grow and that phosphorus product be more available to the plant. So we get some minor complexing and chelating of that phosphorus input in solution, as well as help with root growth and stimulating root growth, so we have more interception of that applied phosphorus and better breakdown, as well as pushing the soil microbiology and helping it to build phosphorus availability. So amino acid complex improves nutrient uptake and movement. And it's also got soluble carbon in it, improves nitrogen metabolism, as phosphorus metabolism. A very interesting product. And we'll talk a little bit about that now. We've run a couple trials with it. This one was done on strawberries. We did an application, sorry, didn't mean to click back and forth there. Did an application of a quart per acre done in conjunction with a high phosphorus pre-blend that they were applying, and did several different sections of the field, went out, took measurements, and we saw that after a couple weeks, we had about 10% better canopy size out of the areas where we had applied the Expect in with that high phosphorus application. So we're pretty happy with that. We've also seen in an assortment of other crops, this is sugar beets, I think, where we've just seen better root development when combined. This was I don't remember when this application went out, but they put in 16 ounces of Expect with their 1137. Look at that. And we ended up with a, you can see here, much better lateral root branching, just a more vigorous root structure on that plant versus the control sections. So I'm pretty happy with Expect. Expect also, you can see at these rates, is a very economically affordable product that can be a minor cost input with a huge ROI with just a healthier root system. Moving into some of our replicated Redox results here, we phosphate input it's a major input in many different crops. And I think that some of the numbers that we'll talk about here and kind of reducing units of phosphorus can be kind of hard to conceive of, but I think that we're going to talk about 3 key trials that we've done here showing efficiencies. And I wanted to start here with the strawberry trial. So we did this here in Oxnard with David Holden, with Holden Research, and we looked at a complete program approach to nutrition with Redox products. Part of that was comparing Redox used phosphorus products, notably Rutex, but also a product called DiCap that we used in season as well, that we're not going to have time to talk about today. We reduced kind of the units applied significantly through using these products, but still hit a similar budget dollar to the grower standard program. Now this is competing with products like MKP, monopotassium phosphate is a major in-season applied phosphorus product for strawberries, as well as several other kind of standard pre-blends that use phos acid and other inputs to kind of help with phosphorus nutrition. So what we did, we were comparing to a grower standard program, looked at yield, units of applied phosphorus. So in-season applied units, we had 73% less units of phosphorus applied in the Redox program versus the grower standards. You can see there's about 50 units of grower standard applied phosphorus compared to the Redox program, which I think was around 13 units of phosphorus applied. What we saw at the end of the season, at the end of fresh pick season, was that we had similar comparative yields as well as marketable yields, which means we didn't have any higher cull rates or anything like that. But what we did see was we saw a much higher average return to the grower. Now this was most likely due to fruit quality coming out of stressful rain events, and fruit quality has a lot to do with calcium. As we just talked about, phosphorus likes to tie up with calcium in season, and so or calcium during application. So when you make a big phosphorus application, a lot of the times you will ding your calcium availability, and that can have a cascade of effects on kind of plant strength and fruit quality. We see this a lot in areas where we switch out for phos acid based inputs at planting to something more like Rutex or other products, where we don't tie up a bunch of calcium immediately. We see just a stronger start coming out of the ground. So with that, I want to hand the mic, I guess, off to Jeff to talk about some examples here from potatoes and lettuce in his area.
Thanks, Danny. Kind of moving right along with that, sharing a couple results we have with you guys about phosphorus efficiency on some other crops. The first one we did here was potatoes. We did this with Miller Research, Jeff Miller in Southern Idaho, and we compared a grower standard program to a Redox program. And what we did here was a pretty heavy application of Redox products. This isn't necessarily what we do on a commercial application, but the point here was to see what a complex and chelated and very efficient and protected source of phosphorus would do throughout the season as compared to the grower standard. So we had 13.5 pounds of Rutex, 2 pounds of micro, almost 7 pounds of H85, and 8 gallons of UN32. So we used 15 times less phosphorus than the grower standard. Grower standard was somewhere in the neighborhood of 95 units of applied phosphorus, and we were at 6.25 pounds of applied phosphorus with our Rutex. So even though we had that 93.75% reduction in phosphorus, we maintained yield and quality. So it was a good illustration of what we can do with more efficient products. We're not doing more with less, we're just getting more out of our inputs. So another trial that I've got a little more familiarity with is with some head lettuce down in Yuma. We did this trial 2 years ago, and we got really good results, but we didn't account for the nitrogen in our 1152 that we tried to replace. So this year we repeated the trial. This was done with Steve West at Research Design for Agriculture down in Yuma. And we looked at Rutex and H85 taking the place of the grower standard 1152 pre-plant fertilizer. So the grower standard is a pretty heavy application. they're getting 182 units of phosphorus out there. We're just looking at 4 pounds of Rutex, 1 pound of H85, and then we compensated for our lost nitrogen, and we used 38 units of nitrogen as AMS. And then we wanted to see if we could gain a little more efficiency out of that with our 1 pound of H85. So we also did a trial with 30 units of nitrogen. And we evaluated this for box weight, cartons per acre, and we did an NDVI reading. So as you can see, our applied pounds of phosphorus were 99% less, 182 versus 1.8. But we maintained that nitrogen there, and then we had a reduction on one of them to see what would happen. And across all 3 treatments, results were statistically identical. We had the same yield across all. We had a slight decrease in cartons per acre with the lower nitrogen rate, and the case weights were all pretty similar. But it was pretty interesting to see what we could do with that drastic decrease in phosphorus in that early season application. And this is their only shot of phosphorus throughout the season, is that one heavy application up front. Just because the way they farm in Yuma, it's hard to get in-season applications on. So we were a little concerned about this carrying all the way through, but as you can see by the yield results, we had no need to be concerned. The 4 pounds of Rutex early carried things throughout the season and did it as good or better than the grower standard program.
Okay. Thanks, Jeff. I think one thing I wanted to highlight here that I thought was really interesting on this one was the cost comparison between the 2 programs.
That's true. I forgot to mention that. We saved $31 an acre.
Yeah. So a lot of the times people, I don't know, balk at cost of products. And in this case, this is just product cost, and this is water run. So, or run with the planter. I don't remember what they exactly with the planter. And so, I mean, this is just this doesn't include the cost of the spreader truck and all that stuff either. This is just kind of product cost. So a significant savings and one less pass through a field. So a time savings as well. So very, very, I don't know, fun results there. We were pretty excited about that. And we do a very similar kind of applications in Salinas with applications with ammonium sulfate and Rutex applications at planting have had great success year over year. So on lettuce, and that's a standard at this point in a lot of acreage. So moving out of that, I do like kind of pulling in a different crop from a whole different part of the Americas here. So these are banana trees, and this is something that one of our partners did down in Latin America. And you can see here, so this is Rutex and H85, similar to the trial we just talked about in lettuce. And they have, here's a banana tree, there's the banana cluster, I guess, on here, and they had significantly more fingers on those bananas where Rutex and H85 were used as opposed to their grower standard program. So I just think that's something fun. I've never seen a banana plantation in person before, so it's just fun to think these technologies are not just being used kind of locally, but are used globally around the world and having equal success in other crops. So yeah, thanks, Jeff. So I wanted to hop into kind of some standard application timings. Rutex, early plant establishment, we're looking 1 to 3 pounds applications, and then maybe early season root flush, similar rates, maybe 1 to 3 times, and then transplant, same thing. We're using a lot of transplant water, can be a very effective tool there. Expect early season root development, as I said, rates are can be extremely low. As a phosphorus primer, it can be pre-mixed in with standard phosphorus inputs at 1 to 3 ounces per gallon concentrate fertilizer. So it can be a very economical way to improve an economical input. And then it can also interestingly be applied as a biostimulant foliar application. It's a couple 8 to 32 ounces per acre as a foliar application. We've also seen some interesting results there, so we can talk about that another day. H85, it's important to remember the role that soil biology plays in phosphorus nutrition and feeding the plant and other nutrition as well coming out of the soil. So maintaining soil health through feeding the microbiology, frequent applications, light rates, or a couple larger rates throughout the season can be very effective. Root growth timings, this can also be helpful. And then nitrogen efficiency, this product blends well with many nitrogen products and can be used to increase that efficiency over the season. So it's also, like I said, available in an organic formulation. We've seen great results with the organic formulation helping with nutrient release, as well as blending in with some of the less soluble nutrients that we can get in on the organic side. Some of the phosphorus inputs are highly insoluble, and also some of the potassiums and the nitrogens. We get a lot of kind of labile nutrition coming out there and kind of kickstarting that soil microbiology to help decompose those nutrients and make them available to plant can be very, very effective. So just want to reiterate, I hope that this kind of stimulated some thoughts and kind of helped fuel your excitement and passion for growing plants. That's what we're here to do and to help you through that. Next week, we're going to have another webinar on calcium this time. Andy Dolph from Washington will be presenting. He's going to be talking about the importance of calcium and fruiting crops. We'll talk some more about strawberries. We'll talk some about some potato work and some other things. And notably this apple trial that was run last year. You can see here we have an orchard treated with mainstay calcium. You can see the cull rate on the ground here. This is after picking versus kind of the grower standard program. So we'll talk more about that trial and how we achieved that, what technologies went into that, timings, plant physiology, where calcium plays a role. So with that, I want to open it up to questions. Say thank you for your time. Thanks for coming on. We hit our 35 minute time slot there. I'm pretty happy with that. And yeah, does anybody have any questions? I got my eye on the Q&A section here in the chat. You can shoot them over there, or feel free to unmute yourself and see if anybody's got any questions.
Danny, did you say you're giving us CCA hours for this?
Yeah, so thank you. Thank you for reminding me, David. So I have applied for CCA hours. I have all of your contact info on the sign-in sheet. I will, once I get approval from it, they're running a lot slower than they do usually. So once I get approval from it, I will send you the sign-in sheet so you can use your app to log on and take and sign in for it. So they didn't get back to me in time I gave them over a week and it didn't come through. So, but yes, so it will be approved for, I think a half hour or yeah, I think a half hour. And I will get that to you as soon as I get it, David. Thank you.
Thank you.
Anyone else?
Hey, Danny, can you hear me?
Yeah, go ahead, leave it.
So on that potato trial, or was it the lettuce? So it had 100 and something units of phosphorus. So those four pounds of the material, of the redox material, was basically for the whole season. It was equivalent to that much input.
Yeah, so we just replaced their grower standard was putting all their phosphorus in that planter band early season because they flood irrigate those fields and they can't get back in there. So they had that one opportunity to make an application. So we put that 4 pounds in there and it lasted the whole season. And granted, lettuce is a fairly short season crop compared to most other crops, but it was enough phosphorus to get it through the season.
Thank you.
Any other questions?
Yeah, I got a question.
Yes, David.
Did you guys have a soil analysis before you started that lettuce trial?
We do. I don't have it in front of me, but it was done on the research farm at R&D for Ag.
Oh yeah, it's done. Yeah, on Steve's place. Okay.
Yep. Yeah, so there wasn't a whole lot there to mine, but there probably was a little bit of background fertility.
I mean, 182 units of P just blows me away. That's how much they're putting down.
350 pounds of 1152.
Yeah, that just blows me away.
Us too, which is why we did this trial, to try to get away from that.
Well, I'm cautious here. I won't say anything else.
Okay. Any other questions that we can help you with? Feel free. Our contact info was there for a minute on the screen. You're welcome to reach out to Jeff or I and ask any questions you have. I'm looking forward to Andy's talk next week. Should be really fun. And yeah, look for the invite in your inbox here coming soon. All right. Thanks for joining. Have a great day. Thanks, Jeff.
Thanks, Danny.